Alright, solving linear systems using the elimination method, and we're going to do this one by looking at addition. So, the very first thing you have to do is you have to make sure that your two equations for the linear system are arranged in standard form. Standard form is when the x and the y are both on the same side, and then the constant term is over here on the right. Once you have your equations lined up, then you can go ahead and arrange them where the x's and the y's are right on top. Now, with this elimination method, the addition method is probably the fastest and one of the more easier ones to figure out. Now, how do we know that we're going to use addition? Well, the first thing to look at is to look and see which variables are going to be eliminated when we add the equations together. Well, first thing I notice is that my y values have the same coefficient. They have a coefficient of 3. However, this one has a negative 3 and this is a positive 3. So if I add the two equations together as they are, the y's will cancel out, leaving us with just the x's left over. So we're going to do addition. I'm going to add here, and just basically it's combining like terms. 4x plus negative 2x gives me positive 2x left over. Negative 3y plus 3y adds up to 0. Or we say they cancel out. And then you have 5 plus negative 7 is a negative 2. By using the first step of the elimination process, we were able to reduce this linear system down to a one-step algebra problem. Now using this, we can go ahead and solve for x. I can divide each side by 2. Once I divide by 2, the 2 is reduced down to 1, or we like to say just x. And then if you think of this as a fraction, negative 2 over 2 reduces down to negative 1 over 1, which is really just 1. So we found x equaling 1. Now we have to find y. So what we're going to do is we're going to go back to the original equation, back to the original problem, and we could take either the top or the bottom equation and plug in x equals negative 1 and solve for the remaining y. I am going to take the top just for fun. So if I take this top equation and we do 4x, well, 4x, but we know that x is negative 1. So we're going to replace x with negative 1, and then we have minus 3y. Make that look like a 3. And that is equal to 5. Well, once you plug in x equals negative 1, all you have left is y. And it's now an algebra problem that we want to simplify. 4 times negative 1 is negative 4. Negative 3y drops down, and we get 5 left over here. So now we're looking at a two-step algebra problem. Once I get to a two-step, I usually tee it up, and we're going to go ahead and we have to move the negative 4 over to the other side. So since this is a negative 4, we're going to go ahead and add 4 to both sides. And the 4's are going to add up to 0, leaving us with the negative 3y. Make sure you grab that negative right here. This is the subtract 3y. If you change this to adding the opposite, that really becomes a negative 3y. That's one of the things most students forget to do. And then we have 5 plus 4, giving us 9 over on the right side. And we're looking at a one-step algebra problem. This is negative 3 times y. So to get rid of the negative 3, we're going to divide everything by negative 3. And the negative 3 is reduced down to 1 y, or just y. And then 9 divided by negative 3 is a negative 3. And we have a solution for both variable. So now we're going to go ahead and take that and write out our solution to the linear system as an ordered pair. Every time you write out an ordered pair, we always write x first, and then we write y, and our solution is the ordered pair, -1, -3. Now, you should go back and text -1, plug in for x, -3, plug in for y. When you reduce the top equation, you should equal 5. When you plug in x and y for the bottom equation, you should get -7.